Hello everyone, welcome to next video tutorial on data structure. Uh, the concept is linked list. In earlier two videos, I have explained what is linked list and how the node is created by using structure. It contains two fields like information and link field. How to define them by using structure. Then how to give the alternate name for the node. Then and how to create an empty list. Then we are going to create a new node by making use of get node. Once the memory is available, then we can store that node into the list. Then after that we are going to assign the new name for the node newly created. Then we insert the information field and the link field. After that we have performed different operations on singly linked list, like inserting an element into the linked list from the front end, then deleting an element from the linked list from the front end. Similarly, display an elements of an linked list. These all concept we already covered. In today class, I am going to explain inserting an element from the rear end. So earlier we have seen from the front end. In today class, we will see inserting the element from the uh, rear end. Similarly, deleting an element from the rear end, then displaying the elements of an singly linked list. Okay, so as I told, in the linked list we can perform the both insertion and deletion from both the end. And the second type, inserting a node at the rear end. So if this is the linked list what we have, I am going to insert the new node which is created to the rear end of the linked list. So first step is that so inserting an element from the rear end. Step one is that as you already know, create a new node using get node function. Here once we call get node function, it will ask for the memory allocation. If that memory is available, the node has been created. So this node is created, then this node will be assigned with the name. For the node I have given temp as a name, and it holds by the variable name is temp, we can say. Then inserting the both the fields of an temporary like information field and link field. Temp pointer information equal to 50, here I have stored 50. Then link I have taken a null value. Why? Because it is a single node now, because it is not yet added to the uh, existing one, so it is up to that, it is null only. Then it is an existing list. The new one which I have created temporary will be attached to the linked existing list. From which end? From the rear end. Okay, in order to perform this, what is the first step? Like we always check for while inserting the element whether list is empty or not. If the list is empty, even though I'm inserting from the rear end, check that whether list is empty or not. If the list is empty, means no elements are there in the existing one, then whatever the new one I am adding, that will be the node in the linked list. For that time you have to return temp. If it is empty, whatever the new node I have created temp will be the node in the list. Then second case is that if the list is existing, like here list exists that contain 3 node, then where I'm going to insert the element, I'm going to insert the element at the rear end. For that case, I want to attach into the last node. So I need the address of this last node. So how to get the address of last node? Initially what I'm doing, I'm taking the current variable which holds the first variable, copying first to the current and incrementing the current pointer link up to it reaches to the null character. So here initially current equal to first, then current equal to current pointer link is contain next address. Is it equal to null? No. Again move to current pointer link. That time it reaches to the null. Then we have to stop the iteration. Then what is the latest value of current? Current reaches to the last node of the list. Then once we get the last node, then attach this new temporary node at the end. So this null value should be removed. In this place, I have to provide the link to the temp. So step 4, insert node at the end, current pointer link equal to temp, current pointer link equal to temp. So this one is the new link is established, and at the end, early, we have to return the first variable, because even though the temp is at the last node added, the first remains same. Always we return first. Why? Because uh, we need to access all the elements of all the nodes of an list, and the list always followed by first variable. So return first. Then all the operation which I told in the above slides are given in a single function. Node insert rear item I'm going to insert from the first node we required. So I'm going to create the new node, that is temporary. Similarly, the temporary node has been copied to another node like node current. For that, I have to take node variable. Then yeah, creating the new node, assign the name to it, inserting the new value into the temp. Then temp pointer link is null. This operation is covered. Then uh, after that, we check for uh, list is empty. Then whatever the new temp node I am adding, that will be for the that only node contained in the list that you have to represent here. Then if the list is exist, already three to four nodes are there. With that, at the end I am going to insert the temp node. For that, I have to get the last address, last node address. For this, I will get the last node address. Once we get the last node address, to the last node, I am going to attach the temp with the current pointer link equal to temp. Then only this becomes the complete insertion of element from the rear end. Then delete the node from the rear end. For that, whenever we check for deleting an element from the list, always check for the list is empty or not. If first equal to null, by default list is empty, return null value. List contain only one element. For example, as I told in the previous one, while inserting the element, if the list contain only one element, that time here info is 10, link is null. So first pointer link if is equal to null, indicate that the list contain a single element, single node. Then delete this item from the first node. First pointer info that contain 10, delete it. Then free the first. This had been freed. This node has been deallocated. Then return null value, because if we delete this element, only null value is left. That is why I have to return null. Then if list contain more than one element, now I am going to delete from the rear end. Out of the 50, 20, 10, 40, 30, I am going to delete from the rear end. So this node has to be deleted. In order to delete this, what I required, I need to first get the last node of an linked list. How to get the last node? By making use of copy current equal to first, current equal to current pointer link. Is it equal to null? No. Current equal to current pointer link. Is it equal to null? No. Similarly, it will get null when it reaches to the last node. Here I have to mention the null value, like here I mentioned. So at this point we get the last node of an linked list. But why I have taken previous variable? Because if I delete this last node, then list always ends with a null character. But if I delete this, this becomes left free. You have to assign this with a null character. For that sake, I need the address of previous also. But I can't take them directly, the last and last but one. But if I'm taking the first as a current equal to first, at same time required previous also. Previous is null only. So previous equal to null, current equal to first. So we keep on increment the value until we get the last node of a linked list. While current pointer link not equal to null. So at this point, current pointer link becomes null. We stop the iteration. This will be the current node. Then before updating current equal to current pointer link, every time we hold that current value to the previous variable. Like if we come at this place, the previous holds this value. Whenever current move to next value, previous holds the 20. Like that, previous value holds last but one node. every time it got updated. Now previous is 40. Then previous point, this one becomes, if last node we have to delete, current pointer info is 30, we delete, then free the current, so this has been deallocated. Then this previous is left, previous pointer link equal to null, we have to assign like this. Item deleted is current pointer info, that let 40 is deleted, then free the current, then previous pointer link equal to null, that is this previous become the last node now after deleting this. Then last node always contain null character, for that sake we have to represent previous pointer link equal to null, then always return first. Okay, and all these operations are written in a single function, like case 1 for list is empty, case 2 for if the list contains single element, case 3 for if the list contains more than one element, or you can say more than one node. Then stack and queue using linked list. What is stack? Stack is a linear data structure where element can be inserted and deleted from only one end. So already we know all these operations: insert front, insert rear, delete front, delete rear, and display. So we can make use of either this set of function like insert front, delete front, or display, or you can make use of other end, inserting from rear end, deleting from the rear end, display. We can make use of either of uh, first part of operation or second part of operation. We have to make use of only one end. Then similarly for the queue, insert from one end, delete from other end, like insert from front end, delete from the rear end, and display remains same. Similarly either you can make use of insert from rear end or delete from front end. Okay, and this can be called queue using linked list. I can represent by making use of cases. Case 1 for insert rear, I am using second part, or you can make use of this one, anyone you can make use. Insert rear, so if we call the first will be returned. Then similarly delete front, like I'm using delete front function calling inside, first equal to delete front, then display case for exit. Similarly you can apply for stack also, like case 1 first insert front, then delete front, here you can write delete front, then third one display, or you can make use of this set of function, insert rear, delete rear. Okay, you see how the uh, insertion and deletion from both the end is covered. In first two videos, insert from the front end, delete from the front end we have seen. In this video we have seen insert from the rear end, delete from the rear end, and we know how to implement the stack and queue using linked list. Okay, already this one is these all functions we have seen, just call them in a cases using switch. For same thing you can apply double-ended queue, like if you insert if you make use of all the functions, that time it becomes double-ended queue, then here number of cases get increased. That's it. Thank you. In the Saturday class I am going to solve the queries on it.